Shall I start?
Yes, start, ma'am.
Okay, all right. Hi everyone, welcome to the second live session of social networks. Okay, all right. So the agenda of today's session is, first of all, I'll answer a few of the queries which you have given to us in the Google form. So we do not have many queries this time. So I'll answer the queries which we have. After that, you can go on and ask your questions. Otherwise, what I'll do is I'll actually show you some network analysis on two real world data sets. And both of these data sets are quite interesting. So we will see what kind of, we'll also try to link the analysis of these data sets to whatever you have studied in the course till now. So mainly the presence of communities in the network, selection versus social influence, right, and community detection algorithms. Just a second. I'm just trying to keep the YouTube link open by my side so that I can see your questions. So I have one question from Prashant, which is quite a good question. So Prashant wants to know about the robustness of a social network. So first of all, what exactly is robustness? How do we say whether a network is robust or not? Can we measure robustness with the help of some centrality measures? Centrality measures like degree. So you can just tell me in the chat window whether you are aware with the centrality measures or not. Otherwise, I can also discuss some of them. And then can I do some sort of rewiring in the network so that we can increase the robustness of a network? So now, first of all, what is the robustness of a network? So one might think that robustness of a network is essentially the density of the network. Basically, how many edges you have in the network. More denser a network is, more is the robustness, but that's not how generally it is defined. Robustness is, let us say I start to do some attack on the network and I start removing some of the nodes in the network. After how much time will this network disconnect? And in addition to just studying in how much time will this network disconnect, you can see over a period of time how many connected components are being formed, right? So first of all, the network might disconnect. It will split into two graphs. And now when this network is splitting into two graphs, what are the sizes of those two different graphs also matters. So definitely if you remove one node from the network, it might split a network into one very big graph and other very small graph. In that case, it won't be much of an effect, right? Still, I'll have one giant component sitting there. A network will not be robust if I remove a node and if it gets split up into exactly two equal halves. So we can see when we remove nodes, what happens to this big component with a period of time. How small does this big component get? So greater how I could say, the more quickly the size of this big component falls, less robust is your network. That's how we define it. And then, okay, Cosmic Fluke says last time I talked about a paper where, okay, the paper was from IT Roper students who did a study on which countries will fight in Third World War. Right, I'll give you the link of that paper. Just remind me if I forget to do it by the end of the session. Okay, so talking about the network robustness, it is definitely linked to the centrality of nodes in a network. So let us say I want to figure out which are these nodes in the network which I should remove so that the network just falls apart. Any hints on what I should be doing? Which kind of nodes should I remove? One idea is to simply pick a node uniformly at random and just remove it from the network. Right? Can I do some more targeted attack? Anyone who is in the meeting can also answer, those of you who are attending the course. Live sessions are more of a discussion session, right? Not a lecture. Yes, so Aditi says that I can try removing the node with the maximum degree, right? We can see which nodes have highest degree and we can just start removing them. That's one idea, right? And this degree, which we say, it is one of the centrality measures. Centrality measures is nothing but if I give you a network, can you give me some estimate of how important a node is? How do you quantify the importance of nodes in a network? And degree is one of the most widely used centrality measure and very easy to compute also. How many friends does one person have? So start removing the nodes having maximum degree. Anything else do you think we can do other than degree? Okay, Manju, I'll go and I'll talk about social capital as well. Okay, so other than degree also there are many centrality measures. So I'm sorry, just need to adjust my chair. There is a concept of okay, Aditi says embeddedness, right? Embeddedness is associated with an edge and probably we can use that as well. So in case you are removing, let's say an edge in the network, or let me say instead of removing an edge, I can remove two nodes at once, right? Okay, there is a concept of cut vertex in graph theory. Does anyone know what that is if you have taken a basic course in graph theory? Can someone tell me? The concept is very simple. Cut vertex is simply a vertex which if you remove from the network will get disconnected. That is the definition of cut vertex. Right? And it very much might happen so that if you remove one vertex, the network might not get disconnected. There might be no such node in the network. So consider a complete network where everyone is connected to everyone else. Such a network will have no cut vertex. I won't have just one node which I remove from the network and it gets disconnected. We can define an idea of cut vertices. Is there a set of vertices which if we remove from the network falls apart? So this idea has actually been converted into another centrality measure which is called betweenness. So betweenness tells how important you are in connecting to different parts of the networks. So I'll give you a very intuitive idea here. So not going by the mathematical definition, it simply says that look at all the shortest paths in the network between all the possible pair of nodes and have an estimate of on how many shortest path is a node present. So if I'm present in a lot of shortest paths in the network, my betweenness is high. That is another centrality measure. Yet another centrality measure is closeness. You see what is my closeness to all the other nodes in the network, and how do you say I'm close to other nodes in the network? Again, you calculate my distance from every other node in the network and you find the total distance. Basically, my distance from node 1 plus my distance from node 2 plus my distance from node 3. You add all this up. Greater is the distance, lesser is my closeness. Right? Lesser is the distance, higher is my closeness. So that is another centrality. There are some more centrality measures which uses the idea of eigenvectors and eigenvalues. And one of the prominent centrality measures which falls in this area is called Google page ranking. That is how Google indexes the web pages. I think it's about to come up in the course. So anyhow, we have these different notions of centrality. And now okay, so as of now, I'll be concerned mostly with the technical questions. Babu Vanga, I'll try to address your question if we have time left at the end of the session. So I will tell you some things which you can do after finishing this course. Just remind me if I forget to answer any of these questions. I just don't want to divert from the topic. So the idea which we are discussing is, given that I have so many centrality measures, which kind of targeted attack should I do so that the network falls apart very quickly? to test its robustness, the robustness of the network. Now, should it be degree? Should it be betweenness? Should it be closeness? Or should it be Google page ranking? So in this context, I just now start sharing my screen and show you some things which might appear useful to you. Take a look at this graph. So this graph is from a paper from the journal PLOS, and it actually shows you the graphs on what happens when you do targeted attack based on different centrality measures. So as you see, the x-axis here is what fraction of nodes you are removing. So I might choose to remove 20% nodes or 40% or 60% or 80%. So that is the percentage which you see on the x-axis, and y-axis tells you what is the size of the largest component of the graph. And rather than size, we say what is the fraction of the largest component. Basically, the number of nodes which are there in the largest component divided by total number of nodes in your graph. Right? And do you see what is happening here? So as you see, degree is actually a local centrality measure. It can be computed very easily, and in most of the cases, degree is the best predictor of robustness. So you start targeting the nodes which are having highest degree, the network will fall apart very quickly. So this blue line which you see here shows you that if you just remove about 20% of the nodes having highest degree, you won't have any node left in the largest connected component. The number of nodes will be very less. And this green line, it comes very close to the blue line. This green line is for the betweenness centrality. Red line is for closeness. This blue line is for eigenvector centrality, which is sort of similar to PageRank. We'll be studying about in the course soon. And the black line, which you see at the end, is about if you start removing the nodes randomly. So definitely, if you randomly remove nodes, you are not doing a targeted attack. It will take more time for the network to fall apart. Okay. Now, the next question was, can we do some kind of rewiring of the edges to sort of make this network more robust? And again, there are a lot of research papers on this topic. So some of the, again, very intuitive ideas are, so you see, if I remove these highest degree nodes, the network is falling apart. So the best idea here would be to have more and more connections between the nodes which are having high degree. So you identify all the high degree nodes in the network and you put a lot of connections between them. Such a network is called a rich club network, and it makes your network very robust to the attacks. So that's one way. People have worked a whole lot on this. We can go on and find a whole lot of research papers. People have even modeled this problem theoretically. They have also applied optimization algorithms like swarm optimization to figure out how this kind of rewiring should be done. And again, there are two ideas. One idea is to have some additional edges in the network to increase the robustness. Other idea is just to rewire the edges and to see how well you can do with the help of that. Okay. Okay. Talking about the concept of social capital. So social capital, so let me know if this, if Prashant is present here, let me know if you have any other question regarding the robustness of a network. Otherwise, I'll move on to the second question. Let me just go back to this window. Okay, Aditi says, what is V here? Let me see. V in the graph. So yeah, I can refer back to the paper and then try to see what V is. So I haven't read this paper in complete detail. So I just explored it to answer the question. So I can go back to the paper and tell you what exactly V is. So there are a whole lot of parameters in these experiments, but I just wanted to convey you the basic idea what is happening. Okay. So I can return back. Okay. So social capital. So social capital is actually a concept which says that you can actually use these networks as some kind of capital. And what do we mean by that? So see, just like money is a resource, time is a resource. Can you use a social network as some kind of a resource? Can a social network benefit you in some way? So let me ask you a question here. I don't know whether we discussed this question previously or not. So it's just a hypothetical situation. So let's say you are in a school and the entire school is set on fire, and all of you have been evacuated safely. All of you are now standing outside and your school is still burning. So you have to curb that fire, right? And now, in order to curb the fire, let's say there are no telephone facilities, the school is in a remote area, you do not have any internet, there are no fire brigades around. What you have is at 500 meters from the school, there is a well with a lot of water, and you have an ample number of buckets. So, can you think of what might be the best way to curb this fire? The one idea is definitely everyone is running with their own bucket, getting water, spilling it on the school. But can you think of a better way? Some kind of an algorithm? Anyone? I hope the question is clear. Exactly, right? So you say everybody stands some distance away and you pass the bucket, right? So you make a line and across the line you are passing the bucket. So do you see that this algorithm where you are standing across a line and you are passing this bucket, it's actually a network. It's actually a line network. So there are whole lot of nodes and every node is connected with one person on the left and one person on the right. So you see, you have this network, if you look at it, is something more than a crowd and it can accomplish a purpose. So this is the capital here, right? I do not have, I'm not buying any time. It's not about having more money. It's just about connecting the people in such a way that you can achieve something. So in this way, this entire network, it's sort of acting as a social capital, right? So definitely this network here, which we are making, it was actually used in the previous time. It was called a bucket brigade network. People actually used to use this technology. So this is one kind of social capital. So social capital is all about, again, can I rewire the connections in such a way that I can achieve something out of a network? So as an example, there had been a study which tried to connect the density of a network. Density is sort of, you can, for a network, you can assume the density to be the number of connections in a network. So let's say I have an organization. It can be a company, it can be a music production house, it can be certain people who are collaborating on a research paper or a project, and I can always show all these organizations as a network where if two people are friends, I put an edge between them, otherwise not. So can you look at this friendship network of an organization, and do you think the number of edges in this network has something to do with how successful that organization is? So it's an interesting question. And again, people have studied this particular question and they have shown that if you have an organization and if in the friendship network of this organization, let's say you have too few ties, only a few people are friends with each other, the organization will fail. But if there are a whole lot of ties, almost everyone is a friend with everyone else, then also the organization will fail. The best way is to have a nice threshold, something in between. So they did this study and they have shown that this same results they apply to a number of settings. So they have done these experiments for Broadway musicals, but yeah, the same experiments they also apply to the educational settings where people work on a paper together, right? So again, the idea is, can I play around with the nodes and the edges in a network so that I can actually achieve something out of it? In that case, we say that we have built a social capital. Okay, and any other questions? All right. So what I'm going to do next is I'm going to show you two data sets and some initial analysis on these data sets. So one of these data sets has actually been collected by me with the help of a faculty who is working in an institute. And the second data set will be a Twitter data. So I'll show you some analysis. So the idea here is you will see how exactly to apply the principles which we have studied in the course to real world data sets and what kind of things can we infer. You can always, take up these projects in case you are in your BTech, you can take up these projects as your final year projects. If you are doing research, you can delve a little bit deeper. You can do more analysis, publish papers out of this. So the idea is these ideas, they can be pursued at any level at which you are studying. Right? Just the depth of analysis can differ. So my first data set, which I'm going to show you, it is from an educational institute where with the help of some student volunteers, we have collected some actual data of who is a friend with whom, basically the friendship network of students in their 3rd, 5th and 7th semesters. So again, we have network at 3 different timestamps and we are trying to see how these friendships, they change as students, they go from 1 year of their study to another. We also have some more information regarding these students, like what is their gender, what is their locality, whether they are lateral entrants, how many backlogs do they have, and we also have their marks in all the subjects. I hope the live streaming has started. So Aviral says always is waiting for NPTEL-NOC IITM and the stream is stuck. And it shows the same to me. So it's not reflecting on YouTube. Can someone check? Okay. So I'll continue. I'll share my screen and then show you. So the data which we have collected, it was in a CSV format, but I'm sorry, I muted myself. So I'm not going to show you the data in the CSV format. The data I'm going to show you is in the GML format. And I hope all of you are well aware of the GML format of data storage. So most of the times you'll find these online data sets in the GML format. So let me actually show you one file here, which belongs to semester 7 of the studies of the students. So let me just open it and show you. I hope my screen is visible. I will share my screen. No, just a second. I'll share my screen. Yep. So this is the GML file. Just increase the text size so that you can see it. So all the nodes and edges are listed in this file. As you can see that this is the first node in my network. We have anonymized the names of the students. So you won't be seeing the actual names. Every name will come up as a string here, which is like 1, 2, 3, so on and so forth. For each student, we have a gender, locality, all such things. I go down, you have more and more nodes in this network. Right, so we have around 128 students data in this network, and here you see I have all the edges in this network. Right, so let's see what all can we infer from this network. I have the same information for semester 3 and semester 5 as well. One thing here. So this is another package I think I talked about in the last live session. You can also use, with time, if you are planning to do more in-depth analysis, you can switch from NetworkX to iGraph. NetworkX is sort of easier to use, but iGraph is faster. And I personally like using iGraph in R rather than iGraph in Python. The reason being R gives you more interactive floats. As I'll show you, you can move around the nodes and edges as you like. And moreover, somehow for iGraph, the R community is more active than the Python community. So you'll find more code online for R iGraph. Anyways, so I have these 3 networks which I'm reading. I'm just running this code again. And as you see, let me actually plot this network of 3rd semester and show it to you. It's not an animation, it just takes some time to organize the nodes correctly. Yeah. So this is the network. So this is the 3rd semester network of the students. And as you can see that I have a whole lot of isolated nodes here. So these people, they didn't report that they are friends with anyone, nor did anyone else reported they are friends with them. Here, these are 2 people. So both of them consider each other to be their friends. Please note that this network, it is directed. It means that if, let's say, Abhilasha says Ram is his friend, Ram need not say that Abhilash is my friend. Right, so they need not be bi-directional. So as you see here, this person 26 considers 13 to be his friend, but 13 doesn't consider him. Rather, this node 13 is very interesting here. A lot of people consider this node 13 to be his friend, but 13 only considers a few of them to be his friends, his or her friends. Anyways, so first thing what I was interested, so can you give me a few questions, what all we might want to study on such a network? So you have network in front of you. And I have also told you some other traits we have, like the gender of the people, locality of the people, what all would you want to study? You can also answer in connection with the videos of the course with which you have seen till now. Any questions? Okay, so Aditi says we can suggest some friends to these isolated nodes, correct? That is one thing we can do. So for these isolated nodes, is there some way how we could sort of suggest them friends? Okay. Any other thing which you want to study? So more on a network level. Okay. So I told you that, see, this is not necessary that if A says B is my friend, B might not say that A is my friend, right? So I might want to see how many of these edges are bi-directional here. So we call that reciprocity. What is the reciprocity here? What is the degree to which people consider each other friends, right? So here in this tab, I have shown you the reciprocity for these networks in 3 different semesters. And you see something interesting here. For semester 3 and semester 5, reciprocity is almost similar. It is 0.72. But something happened here in the last year of their course that the reciprocity suddenly fell to 58%. So as these people move further and further in their course, during the fag end of the course, something is going on. So here is a time when a lot of people consider others to be their friends, but those others do not consider these people to be their friends. And we try to talk to the faculty members of the institute to sort of understand what could be the reason behind this. And one of the reasons they said might be because of placements. So if 2 people, they get placed together in the same company, right? So there's a chance that they'll become friends with each other. And furthermore, placements can also induce some sort of stress on the relationships, and some friendship connections might be broken. So that is what happened at this last timestamp in this network. Okay, any other thing which we can study? So remember, can we measure homophily in this network? Do you remember how do we measure homophily? So I told you that we have these traits like gender and locality for these people. So can I see whether these students, they are becoming friends more on the basis of their gender, or are they becoming friends on the basis of their locality? We have one more attribute here, which is called section. So as you know, most of the times the entire batch, it is divided into 3 or 4 or even more sections. So is there a more homophily induced by these sections, right? And can we measure that homophily? So if you remember, we measure homophily by looking at what is the fraction of intra-class ties. So basically, let's say there are boys in a class, girls in a class. I see how many connections are there within boys, how many connections are there within girls. You can divide it by the total number of connections in the network, and that will give you an idea of whether there is more intra-boy and intra-girl connections. So if that is the case, then there is a gender-induced homophily in the network. So what I'm going to show you here is homophily based on 3 factors. One is gender, other is locality, and we can take one more, which is section. So please do not worry about this code here. I can always pass on this code to you. You can play around with it. R might also be a new language for you. So just focus on the results I'm showing you. We can talk about the code later. Okay. So how to measure homophily? There is a metric which is called assortativity for this. Right? Assortativity is something more than simply the fraction of intra-class ties. It is the fraction of intra-class ties in your network minus how it would happen if it was a random network. But again, let's not concentrate more on the definition, but to see more about the application here. So I want to find the assortativity of, let's say, this network G7 on the basis of, let's say, on the basis of gender. And you see, I got a value of 0.6 here. So the range for this assortativity is typically from -1 to 1. -1 if the network is highly disassortative. Basically, when boys are becoming friends with girls, but not with each other. Same with the case of girls. So that we call a disassortative network. Assortative network is where there is a whole lot of gender homophily. So if the network is 100% assortative, you will see a value of 1. Here I have a value of 0.6, which is also a decent value. So I see a whole lot of homophily based on gender. And let's say I want to see whether based on locality also do I have the same amount of homophily. You see, based on locality, it is more. So people are becoming friends based on gender, but they are becoming friends more based on locality. So locality induced homophily is higher, and what you will see is section-based homophily is actually the highest, very high, and it is bound to happen, right? Because these students in different sections, they are studying in different classrooms. So when they study in different classrooms, definitely within classrooms, you will see more friendships emerging. Across classrooms, there will be lesser number of friendships. So these are the different values of assortativities which I have. And then you see, in the actual network, the friendships which are being made are not just based on this idea of only gender or only locality or only section, right? It's a combined effect of all these 3. So if 2 people have the same gender, have the same locality and are in the same section, so you'll see a maximum amount of connections between these kind of people. And often when you have these real world networks, you most of the times do not have this information. So you do not have the gender, locality and section information. Let's say you are collecting Twitter data. There you won't have all this information. Even for us, collecting such a data was a tedious job because people generally do not want to reveal all such information. Rather, they don't even want to reveal who are their friends. Anyways, so once we have this network where we do not have these traits, then can I sort of figure out which are the clusters in the networks, which are the communities, right? And I think there was one community detection algorithm which was discussed in the course, which is edge betweenness, right? So let me actually not use any of these traits So assume that I do not have any of this information. I don't have gender, locality, and section. Just based on the structure of the network, I want to identify the groups of people. So look at this network here. Can you just look at this network and tell me, okay, well, these people are in one group, these people are in another group, yet these people are in another group. Is that possible? Right? So for that, I'm now going to use a community detection algorithm here. So there are again a whole lot of community detection algorithms. You can see all of them listed here. Right? Some of these are greedy algorithms, some of these work bottom up, some of them work top down. So I'm going to use the one which we have discussed in the course, the one which is based on edge betweenness. So you start removing the edges which have the highest betweenness, break the network and give me the communities. Once I have the communities, I plot my network along with these communities. Just a second. So if you look at community membership here, it shows you the communities of all the nodes. So these three nodes, they are in all the nodes, they are in community number 1, community number 2, so on and so forth. I'm just trying to see why I am unable to plot this. Yeah. So I have this graph here, right? And you can see a whole lot of communities here which are detected by the algorithm. Right, all the communities, they come in different colors. So anyways, once we have deduced this community structure with the help of edge betweenness, I would also want to know how rich is this community structure? How good is this community structure? Right? So see, if I apply the same algorithm on a complete network where everyone is a friend with everyone, even then it will spit out some communities. It might say to you, okay, I have 3 communities in this graph or 4. Depending on which algorithm you are using, you'll always have some result, but we should also know how good the result is. Basically, can you tell me how modular this graph is? Does it actually have communities or not? So for that, we have another measure which is called modularity. So if interested, you can talk in detail about assortativity and modularity with me sometime later, or maybe on the discussion forum, you can write questions about this. But the point is, if you take a deeper look, assortativity and modularity are the same things. Their formula is also the same. So we can discuss about this later. So right now, let's see how modular this graph is. And you again get a value in the range of -1 to 1, and the value which you get is 82% here. So these are some things which you can do. Okay, what more can we do based on what all has been covered in the course? Another interesting thing which you can do on such a network is, can you figure out whether there is a social influence in this network? Any idea how we can do that? You recall selection versus social influence. For which trait can we apply them? To say definitely we cannot apply this selection versus social influence question to gender, locality, or section. Right? Selection means you become friends because you are similar. Me and you, we have similar body weight. Let us become friends. That is selection. Right? Social influence is, one of us is like a particular way. Since I am friends with them, with time I adopt their attribute. So let's say you get very good marks and I become a friend with you. I also start getting good marks. Right? And we have the data. So we have, if I show you all the attributes which we have for the vertices of this node, you can see here. So these are all the attributes, and we have the marks of these students in different semesters, in different courses, so on and so forth. And we have the network over 3 different time stamps, right? And we have the connections which are changing significantly in the 7th semester. So now, can you take a look at this network and tell me a way in which I can measure, especially in terms of the marks these students get, the percentage of these students, whether there is selection or social influence. You can figure out a way for that. If you remember the YouTube case, sorry, the Wikipedia case study which was discussed in the course. Do you remember? Does anyone remember what we plotted there to see whether it is selection or social influence which is playing a major role for nodes to become friends? What did we do? So if you remember what we did on x-axis, we had the timestamp and there was a particular time which tells me the exact what I would say instant at which these two people become friends, and on the y-axis you had the similarity. So if I had the book, I could actually go and show you that. So refer back to the notes after this session. So I'll repeat, on the y-axis, I have the similarity between two people. On the x-axis, you just have time. And there is this one time during which these two people become friends. So what we simply see is, were these people more similar before becoming the friends, or did they become more similar after becoming friends? And that tells you whether there is selection or social influence. If they were more similar before, then it was selection. But if they were less similar before and they became more similar afterwards, then it is social influence. Right? So you can also do a study of those phenomena using such a data set. Any questions? If not, then I'll move on to the second data set. Okay, so many of you want the link, right, of that paper where they study this World War III. Do not worry, I'll post it on discussion forum after the session for all of you. Okay. Simran, can you put a word in the YouTube live chat for the pattern of the final exam? Some of them have this question. Okay, I'm moving on to the second data set. And since we are talking about networks and we are talking about social networks, let's talk a bit about the online social networks as well. And one of the major online social networks, so one definitely is Facebook, but I'm going to talk about Twitter because the data of Twitter is more easily obtained than as compared to Facebook. So let me ask you, has any of you ever tried scraping the data from Twitter? If yes, how? So let us say I want to see certain hashtags which are trending on Twitter. Right? What all kind of study can I do based on social networks? And how do I even obtain that data? I'm going to show you a few tools for that. So one idea is to definitely get a Twitter developers account, right, and do some data scraping using that. But Twitter developers account and doing data scraping with that has some drawbacks. So one is, if you do not have, so Twitter has different levels of access. So if you have the highest level of access, which is actually difficult to obtain, you can scrape a whole lot of data. But with the lower levels of access, you don't get a whole lot of data. Furthermore, you get the data only for the past 7 days. So I'm going to show you an easier way of working around this. I'll again share my screen just a second. So there is actually this application which is built on the top of Twitter APIs, which you can make use of. So it has been developed by Indiana University. So they actually collect a whole lot of Twitter data. They have an archive of that, and you can find a whole lot of hashtags and tweets starting from the year 2010. Right. So take a look here. So you can go on and explore all these tools. So some of them study the spreading of fake news on Twitter. So they have some of them checks how polarized the social networks are. Polarized essentially again is related to communities, right? And they have this tool which is regarding misinformation for COVID-19 vaccine adaptation, so on and so forth. So I'm going to show you some data analysis with these two tools here. One is the trends and other is the network. So these are more general tools here. So going to trends, if you simply want to see which kind of hashtag is currently trending, right? So if you have a hashtag, you can simply check for how much it is trending. So as an example, I'm taking a hashtag war here. Let me see if I can. Yeah. So I'm taking this hashtag war here, and you can give it some start date and end date, the period during which you want to study the spreading of this particular hashtag. It consumes some bandwidth. So since I'm also on a Zoom call, it might take some time. Yeah. So you have this graph here, right? So this shows you how this hashtag war, it has been trending from January 1 to 30th January. So on the x-axis, you have date, and on the y-axis is the percentage of tweets which have this hashtag war in them. And you see, do you realize that something actually happened on these dates close to 26 January that people talking more about this hashtag? Then you can look for events or the newspaper clippings where you could actually figure out why did this happen. And let me go to Feb and see whether there was some change in the spreading of this hashtag during this time. Do you see a very interesting pattern here? So let me also add the March data to it. So I'm adding from 1st March 2022 to let's say yesterday. Right? Yesterday was 22nd. So 1st March to 22nd March here. Can someone tell me what is happening here? So if you look at this network, something actually happened on 24th Feb. People started talking a lot about this particular hashtag, and then again with time it came down, right? And as all of us might aware of that this 24th Feb was actually the day when Russia announced its invasion on Ukraine. Right, so if you look at the hashtags like Ukraine-Russia crisis, they're the one which are trending a whole lot today. And let us say you want to do some research or you want to do a project on that, you want to see on Twitter how people are talking about this particular hashtag, or is there some kind of a hate speech being spread, or can you study how sentiments are diffusing in the network, so on and so forth. We can do some analysis with the help of this another tool, which is the networks tool here. So it's again very interesting in the sense that you can give a hashtag here, you can specify the dates, and it can generate three kinds of networks for you. So one is the retweet network, mention network, and co-occurrence network. So please note that it will just give you the network here. So let's actually try it. So I'm giving it this hashtag Ukraine-Russia crisis here. And let's say I want to look at, let's say the retweet network simply. So who is tweeting about it to whom? And I'm again, let's generate this graph here. It will take some time to show up. So you see this network here, a whole lot of nodes floating around. So let me just click on this one node here, right? If you click on these nodes, you also get to see the content of this tweet on the left hand side, right? But again, and see, you already see a lot of isolated nodes and a lot of clusters here in this graph. Now, the point is, I actually want to do some analysis on this graph, right? It's just a visualization of the graph. I might want to do more things on this graph. I might want to see, are there communities of people? How many people are there in one community? Around which particular hashtags do these communities revolve? Are people changing their communities with time? So on and so forth. So what you can do is, you can export this graph as a CSV or a GML file. Right? So I generally again prefer GML format because you can readily read this GML format in NetworkX or iGraph. You can also download the CSV file, right? And you can continue with that. So there is one advantage in downloading CSVs here. So you can also download a CSV, and based on that CSV, you can write certain functions which makes a network from the columns of a CSV file. Again, such functions are available in iGraph and Python. So let me actually download this CSV file and show it to you how it looks like. Yeah. As you can see here, I have all these columns in this file, right? Let me just extend this one also. So I need to convert this one into a number. How do I do that? Okay. So you can actually convert this into a number. It's not coming correctly here, and it will actually give you the actual tweet ID. Let me open it in Notepad. That would be better. Yep. So if you see here, this is the raw data we have, which we just downloaded, right? And it tells you which is the person, right? So it's telling you the username here, the person who has tweeted, the person to whom this the tweet is done, and this next one tells you the tweet ID. With the help of tweet ID, if you have a developer's account, you can also figure out the exact contents of the tweet, and you can also apply some sentiment analysis based functions here. And the next one tells you whether it was a retweet or a quote, right? And you can actually make your network from here and again do some analysis on that, right? And that again, you should sit and think about what kind of analysis do you want to do. So one more kind of a network which is interesting here is the co-occurrence network. Can I see which hashtags are co-occurring together? So let's say I'm talking about Ukraine-Russia crisis. So there would be a number of hashtags which would be floating around the topic, right? There won't be just one hashtag. So hashtag Russia would also be associated with this. You'll also have hashtag World War III, hashtag news, because all these news websites would be talking about it. So can I see which all hashtags are actually floating around with this one, and then again do a study? Are there communities of hashtags? If you apply this community detection algorithm to the co-occurrence network, again, that will give you a decent idea into what are the communities of different hashtags. There might be one news community, there might be one, let's say, Ukraine army community, so on and so forth, right? And as you see, again, this network is quite big. So yeah, one thing here is it does not give you the entire Twitter data. These are 10% of the sampled tweets, the data from there, because the entire data is actually voluminous. So this particular network here, as you see, it has 1000 edges and close to 9000 nodes. And you see every node here is actually a hashtag, right? And it's just telling you which hashtags co-occur together. So as you can see in this particular tweet, hashtag breaking Russian Putin Ukraine, all these co-occur together. And again, you can export this network as a GML file and do some more analysis on that. Let me quickly show you some of the analysis as well. So I previously downloaded these files here. So if you look at this network, it is again the co-occurrence network of these hashtags, but in the month of January, when actually you wouldn't see this hashtag a whole lot, because in January the subject was still quite new. Not a lot of people were talking about this. And let me just show this graph to you. So here is You see, I see clear-cut two communities here in this network. As you see, the first one revolves around the Brazilian president Bolsonaro, who was in the news because of his visit to Russia during the crisis time. And the second one is corresponding to the news. So I can clearly, you see the hashtags being divided into two different communities here. So there's a bunch of community, there's a bunch of people here who are concerned more about what Brazil president had to do in those days. There is another community which is concerned more about news, and definitely these would just be the news websites, right, which are talking about this on Twitter. But if you look at the same co-occurrence network, let's say during March 13 to March 20, you'll actually get a very big network. And it's a very big network. That's why I'm not even going to plot it, because if you plot a very big network, you won't be able to see a lot of nodes. So this new network, it has 1,000 nodes and 10,000 edges. So I'm not going to plot this, but rather, you know, what I can do is, let's look at whether this network is connected or not, whether it has certain is it like one big graph, or is it is broken into some small graphs, right? So you see, this network is not connected. So you can again extract the biggest component from this graph and study that. Generally we do that. You collect any data set, it won't be connected. As you see in the students networks also, there were a lot of isolated nodes. So you take that network and you only study the biggest component. So yeah, we just have 3 minutes left. So what you can do is extract this biggest component, and then you can apply a community detection algorithm, and then again you can see what these different communities of people are talking about. Okay, so these are just some initial ideas which I have. You can think of more ideas, you can discuss more about it on the discussion forum. So I just wanted to give you a flavor of what kind of work can you do. And also for those of you who are very much motivated to take this subject one step ahead, and let's say want to combine the ideas of machine learning with graphs, there is this very nice course by Gilles Lescovec, who is one of the leading researchers in this area, which is called Machine Learning with Graphs. It is offered by Stanford University. You can consider it, you can consider watching these videos once you are finished with this course, because once you are done with this course, you'll have all the prerequisites to actually go and study, do this course. Definitely machine learning is also a prerequisite. So once you have a basics in network science and also a basics in machine learning, you can go to this course and learn more about it. All right, so with that, I'll stop. If you have any more questions, you can definitely post them on discussion forum and we'll answer you there. I've also placed the link of the paper in the chat window, right? Someone was asking for. Gautam was asking. So the link is in the chat window. Okay, people will stop. If you have any questions, you can leave them on the discussion forum. If you have also some suggestions for the live session, you can also put them in the discussion forum.